Hey guys, in this video we're going to talk about how to solve and deal with absolute value functions. These are the functions that look like the letter V. So the way that I like to remember these is that they will look like this for the most part. Maybe it's upside down or pointing up, but absolute value functions look like the letter V, which means that there's two sides of the graph. There's the negative side of the graph and the right side of the graph. So when we're solving for these problems, we're usually looking for two answers, usually that's the case. So let's get started with Unit 3 review. Let's talk about this section of the review of your semester exam. Tomorrow we're talking about Unit 4 on quadratics, and we are done. So let's begin. So here for questions 18 to 21, or 18 to 19, we're looking at solving the absolute value equation. We're looking to find out what x values here will give me 2 as an answer. Now remember, there's two possibilities. So what I'm going to do is I'm just going to put this on Desmos. I'm going to show you the fastest route possible. If you want how to do this by hand, you can watch some of my YouTube videos to show you how to solve this by hand. I'm going to show you the fastest way possible, which is on Desmos. So what you do is you type this as two equations. You're going to type in the left-hand side separately and the right-hand side. So you're going to write this as a function. All right, so we have f of x equals x plus 5. We have the absolute value of x plus 5. There's my v that we were talking about, right? That's my function. I want to figure out when is this function going to equal 2. So I make another f of x. We say, when does it equal 2? All right, you see how right here we have x plus 5 equals 2. Now we have these two functions. When will this function equal 2? And you see here through the intersection points, it crosses it twice. The function will equal 2 when x equals -7 and -3. That's it. If these lines did not intersect, it had no solution. If it intersects once, it has one solution. Okay, that's really what we're looking for. Let's try number 19. When does this function equal 24? We did this as a warm-up today, but I'm going to solve it again just in case you weren't in class to do the warm-up. I'm going to delete this. And this side, I have -3. 4x minus 20. Zoom out a little bit. That function is going to be an upside down v. As you can see, I want to know when is this function, when will this function equal 24? So f of x equals 24. As long as you write it as two separate ones, you can see the two different lines and you can check to see if they intersect. So by the looks of it, we have the function down here in the bottom, the other one 24 on the top. This has no solutions. Because they don't intersect, there's no solution. There's no point ever where this function will equal 24. This function can equal -24, but it will never equal positive 24 because it's pointing downward while this one is on the top. Let's talk about this right here. Graph the given absolute value inequality. When is this going to be greater than 2? Now, I can go on here as well. I didn't really show you how to do it on here, but what we can do for this one right here is we got to remember two rules. When it is greater than, you're going to shade towards the outside of the graph. And when it's less than, you're going to shade towards the inside of the graph. So what we want to do here is we want to split this into two parts. The negative side and the positive side. On the negative side, we have x equals 2. Sorry, -2. And on the right side, x equals positive 2. There's nothing here that we need to solve. So since it's already isolated as x, we can just split into two parts. What does that tell me? It tells me that At -2 and 2, I'm going to have two solutions. So I'm going to put 0 here in the middle. I have -1, -2. At -2, I have an open hole. And at +2, I also have an open hole. How do I know that it's an open hole? Well, this has no equal symbol because it's just greater than. There's no actually an equal symbol there. We're going to have open hole versus closed hole, right? Open dot versus closed dot. And now because it's greater than, we're going to always shade towards the outsides. Anytime we're dealing with greater than, we shade outside of the solution. And that means that anything in that shaded region is an answer in this problem. So x can be less than -2, or x can be greater than 2. So choose any number that lands in that realm. Like you can plug in over here, we have like a 5. If you put 5 in there, the absolute value of 5, I can pull that over here so I can show you. The absolute value of 5 is 5, right? Remember, the absolute value changes any number to the positive version of itself. If it's already positive, it just stays positive. Is 5, let's change this color. Is 5 greater than 2? You bet. Now let's choose another number, like over here, like say -10. The absolute value of -10, if I plug it in here into the original problem in red, the absolute value of -10 turns into 10. Is 10 bigger than 2? Absolutely. So this is my solution set. You can see the solution written as inequalities or in graphing, where you can see anything in the shaded region is going to work. Let's try the next one. 21. Graph the absolute value inequality. The absolute value of x is less than or equal to 3. So I break this into two parts. The negative side and the positive side. So I have x equals -3 and x equals +3. I'm always going to change the inequality to an equal symbol just in case I need to solve the problem more. Here, because they're just x equals and x equals, we don't have to solve anything. We just have 3 dots. I'm going to put 0 here in the middle. 1, 2, 3, I have -3, and 1, 2, 3, +3. Now, because this one has the equal symbol, at -3 and 3, we're going to put the closed dots. Unlike this one that had open dots at 2. Open circles means it does not include those numbers. You can put anything bigger than 2, like 3, 4, 5, except for 2, or -3, -4, -5. Does not include 2. Here, I can include those endpoints. Now, when it's less than, the less than symbol is actually going to change the shading, right? That shading will now be within the problem. It'll be in here. The shading happens in between. While over here, the shading happens on the outside. Let's say that I want to graph this. Let's just to see what they would look like over here on the graph, right? I have the absolute value of x for number 20 is greater than 2. Did we shade correctly? Did we shade from, I need to zoom in a little bit so you can see the numbers. See how it's like 2 and -2? Did we shade towards the outside of the number line? Yeah, that's exactly what we did right here. Now the reason why it's dotted, right, is because we have open circles at 2 and -2. And the shading goes in both directions, left and right. Let's try another one. Let's try x is greater than or equal to, sorry, less than or equal to 3. Notice how now the answer, the shaded region, is between -3 and 3, just like in our graph right here. So you can really do all of these on Desmos if you know how to read Desmos. When it's all solid line, it's a closed dot. When it's a dotted line, it's an open circle, that kind of thing. Let's try our next example. So here we want to solve this right here. And we want the answer in interval notation. We want to be able to do an inequality and interval notation. So when we're solving for this, right, we want to break it into two parts of the graph, two solutions. I'm going to go over here. Now let's just do decimal since it's already faster. Type it in as 6, 18 minus x greater than or equal to 30. Okay, now there's a lot. I need to zoom out here a little bit because there's a lot of numbers to worry about. Here I can sort of start seeing that the answers are going to be towards the outsides, right? If I zoom in a little bit so I can see what numbers these are, these numbers, right? This is 11, 12, 13, and 23. So 13 and 23. If I were to make a number line, I would have this. At 13 and at 23. Notice how at 13 and 23 we have solid lines. So we're going to put solid dots. And since it's shading outward, we're going to shade to the left and shade to the right. All this really means now is how do we interpret this in interval notation? This means that x could be anything in the shaded region, anything less than 13 or anything bigger than 23. That's going to be our solution. So how do I show that in inequality and interval notation? Inequality notation would mean this. If we did this in inequality, we would say x can be anything less than or equal to 13, or x can be anything bigger than 23. The answers are going to lie in that range. Interval notation uses parentheses and brackets because this one goes to the negatives, right? Anything less than 13 can go to negative infinity. So in interval notation, we would say negative infinity to 13, and I would put a bracket because it includes 13 versus parentheses if it was an open circle or a dot. And then for the second part, x is everything bigger than 23, which means this can go to positive infinity, right? Positive infinity, negative infinity. So I would say, this is freezing up for a second. I would say from 23 to positive infinity. Remember that nothing is ever included at infinity, so we don't put brackets around infinity. Let me correct that for you guys. There. So this is interval notation. This is inequality notation. They both just describe what this graph is doing, meaning they both describe that x can be anything in the shaded region, anything on the left from 13 and anything on the right from 23. I hope this graphing part clarifies things for you. I'm not doing this by hand, but I can show you how to do it by hand on my YouTube channel. You can go watch those videos. It's called solving absolute value inequalities. Okay. Let's look at this next way. What happens when the solution, what kind of solutions do we have, right, when the expression equals a number? So let's just change that expression to any expression. Let's just say that this equals, right? Let's just use this as an example as f of x equals the absolute value of x. Here. If this equation were to equal a number, let's choose 10. How many solutions do I have? 1, 2. I have 2 solutions. So case 1, let's draw a sketch of case 1. When the absolute value equals a number, it will have 2 solutions. Right? You can always just graph it. Case 2, let's just change this to equal to 0. Here, notice how they'd only cross once. So we would have one solution. And then lastly, if this absolute value ever is equals a negative number, right? They're opposites. It would be a no solution. Now, I don't like to memorize these rules just because things can change. Sorry. Just because things can change, right? The absolute value doesn't have to be positive here or negative for it to mean no solution or two solutions, because what if the absolute value is upside down? If we have an absolute value of v and it equals a negative absolute value can equal a negative because it's pointing in the same direction. They're both in the bottom. Here, it would equal a positive number. So notice how the absolute value is negative. Let me just change this notation for you so you can see it. Absolute value of x. All right, see how this absolute value is negative, so it's pointing down, and the number is positive. So they're, as long as, if they're ever opposites, then you have no solution. If the symbols are the same, then they have two solutions. And if it ever equals something like 0, it means that it equals one solution. The best thing to do here is always graph them and just to see how do the lines intersect, if they intersect. Do they intersect once? Do they intersect twice? That kind of thing. That's all I would worry about. Let's talk about this last portion, 25 and 26. Remember, ignore 24. We did not talk about that stuff. This is just talking about transformations. What is the function, right? If it was vertically stretched by a factor of 3, we have a vertical stretch of 3. Remember, our general function is f of x equals a absolute value of x minus h plus k. We're dealing with a, h, and k for these problems. So for 25, we're looking at vertically stretched by 3, which is this right here. We're going to put a 3 for the a because it's vertically stretched. And then we have it's vertically shifted down 2 units and horizontally 4 units. Horizontal is the h. So they're horizontal to the right. Right? If it's 4 to the right, we're going to do the opposite. Instead of positive 4, we're going to say x minus 4. And then because it's being shifted 2 units down, we're going to do minus 2. And this is our function. What you can also do is you can graph this on Desmos and see if it's actually true. Did it move, right? Is it thinner? Is it narrower? Did it move to the right and did it move 2 down? That's all this is. Number 26, very similarly, we're just going to analyze different words here. This function moved to this. Describe the transformations for this function. So describe what is happening when this function, right? I want to know what is happening there. Now, the 4 means it's going to be stretched. The minus 2 moves it 2 units to the right, and the minus 3 moves it 3 units down. You can also just graph it and say f of x equals 4. See how it's narrower? It just got smaller compared to this one, right? Adding the 4 made it stretched. The x minus 2 moves it now 2 units to the right. See how this moves to the right 2 units? And then the minus 3 is going to move it down 3 units. So it started at the center, it moved 2 to the right, 2 down, and it got narrower. And that's really what you're describing here. You're describing the transformation that occurred. So I would say vertically stretched, vertical stretch of 4. I would say 2 units to the right, and I would say 3 units down. So these two are very similar, they're just opposites. One describes it, you write the equation. One is the equation, you describe it. All right, guys, this is it. Remember, you can go to my YouTube channel and you can go check out more problems like these if you want to have more examples. Okay, I hope this helps with your review and prepare for the final exam. Please let me know if y'all need anything. And as always, I'll calculate.